Well, thank you very much. In my talk, I would like to share with you how we get to the 25 Moonshot gold candidate. This 25 Moonshot gold candidate was designed, and there's some idea behind it. Let me first mention that those are the people, and now the committee health. We have like a few people, so a number of people who's getting involved in this, and we have 4 meetings. And of course, it's not just 4 meetings. There are like a number of hours and hours discussion with the each ministry and the cabinet office, and then we compile the report, and then they get all the numbers in, and then come up with the possible candidate of the Moonshot. The basic principle, as we have been already mentioned, is it has to be inspiring and imaginative. At the same time, we have to achieve it. That means have to be credible. We can't really do sci-fi thing which against the law of physics, which can really achieve that. It have to be scientifically realistic and technologically achievable. It's probably not going to today, not going to be 5 years, but probably 20 years we can achieve it. At the same time, we're going to have like a very big goal. At the same time, we can take low-hanging fruit, so to speak, in next 3 to 5 years. So a little bit bigger foods in 10 years' time. So people can keep going for that. Okay. Now, first of all, our concept is to understand the basic things, to understand the modality of the research and development. Moonshot is not the only research program we have in Japan, or it's not our only modality. So, there are different kind of modality to support a different kind of science and research. Science and technology research, Moonshot is the one we're talking about. At the same time, if we agree that some specific topic, like a stem cell or quantum computing or other things, is important, we're going to spend money on that. With the focused area research, there's a lot of big research funding in this area. At the same time, the exploratory research, each funding may not be that big, but this is based on the curiosity and intuition of each researcher. So they can come up with a really crazy idea. Most of them fail, but they come up with something very interesting, major discovery, and a very disruptive idea. So we have a clear, distinct 3 different modalities of language. This is the first understanding. And among them, we have to manage Japanese R&D spending in terms of portfolio management, as Uema-san mentioned. So we're going to spend money on the Moonshot. At the same time, there should be substantial funding in focus area research. At the same time, exploratory research as well. So we're talking specifically Moonshot research. Now, at the same time, Moonshot is obviously named after the Apollo project, the US space program. At the same time, this Moonshot is different from Apollo as well. In the Apollo project, we just really summarize in a very crude way, and sorry for the little minor inaccuracy of that. It's one goal, we choose to go to the moon and come back. That's important. Okay. And the duration was 10 years to go to the first moon landing. And they have like a follow-up, like a few more landings, over the next like a few years. But we are setting, and at the same time, the nature program was more on engineering to build like a Saturn V, build like all the orbital flight and all the ground stations and all the management, all the technology to do that. So it's a really big engineering project and execution challenge to have like a space science. Okay, so this is actually the big engineering technology program to enable the new kind of science. That was actually Apollo. And in the need for science discovery, of course, there are needs for science discovery, but predominantly technology challenge. That was the Apollo project. Now the Moonshot program of Japan is we have 25 gold candidates. Okay, doesn't mean that we have to do all 25. Actually, we have some priorities, at least in my mind. There are few we can go for now, and a few we should actually better be in a more focused program, some better to be in a private sector, things like that. So we have to really select which 25 to go, and probably which goal to be merged or modified. Then we put the duration 30 years, way more than Apollo project, because what we want to do is push the technology, a lot of engineering integration to enable the new science, enable societal change. At the same time, we want to have a basic research stimulated, so that why we have a longer goal. Therefore, at the end of the 30 years, we have some fruits of the basic research coming into the Moonshot program that enable us to achieve the challenging goal. And the problem with the basic research, you never know if we're going to find what. So like you can't really have a basic research targeting for 5 years. We discover this in no way. So we have like a much longer time horizon. We have like all the ambiguity put into like into the future, but still we are hoping that some of the discovery will actually enable the moonshot in a really big way in the future. But at the same time, in the short term, this is gonna be like a technological challenge, and we can achieve low-hanging fruits and a medium level challenge, which will transform society. Okay, the nature program is techno-social transformation. This is really the big difference. Right now, what we are facing is global climate issue, aging society, and other issues. Technology is not going to solve by itself. Technology and social transformation, industrial change, economic change, all have to be aligned, all have to be convoluted. That means this is a techno-social transformation. That requires a quite different way of looking at things and executing things. And for the science needs, for the initial milestones, but essential for the longer final goal. That is actually the way we design this moonshot. Now, one case study is actually a moonshot program which I initiated together with my colleague in the Japan, the US, and Europe. Is RoboCup, which relatively famous by now. This is the thousands of researchers working on this, and then 250,000 kids actually getting all the education out from program. This is one of the biggest robotics and AI program in the world. The target is by 2050, there will be a fully autonomous humanoid team to win the FIFA World Cup champion in soccer. Okay, now we can talk about the rugby, but like very popular in Japan these days. But like this is soccer, and we start talking about this, or start the project in 1997. The goal is not yet achieved. We have 30 years to go, but initial 5 years to 10 years, we got to spin out like a Kiba system. This is the company automated in the warehouse management acquired by Amazon, which is Amazon robotics now. This triggers a complete change on the logistics system in the warehouse. And then also like Aldebaran Robotics, which is acquired by the Sony. And I think this triggered the SoftBank start investing a big in robotics. So we have like a lot of spin-off company in 5 to 10 years time after the beginning of the moonshot program. So this is something we are kind of envisioning to do the same in Japanese moonshot. Goal is long, but we're going to have a lot of technological and social, outcome in 5 to 10 years, and then we're going to have like a series of startups and change the ecosystem and societal change to triggers. Okay, now getting into the content. Okay, specific topic. Now, we designed this with a sense of urgency. We are having a real problem in Japan where population declining, more aging people. Like this is the aging society, but at the same time, we thought this is the opportunity. That's why we're saying leveraging an aging society. That's why. Okay, so this is a major problem in Japan, and we have a look at the global issues that saved us. We have like resource issues, pollution issues, and climate change. And so that's the second thing. Okay, third one is aside from those issues which we know, what we can do in the science or technologies. We have to explore the science and technology and how we can provide technological platform and new innovation, inventions to push the science forward. And that was the third category. So this is like a three, I think, like in a logical step. And let me look into the first one, leveraging a society. The issues are three. One is we have a labor shortage. Second, medical expenses is growing. Okay. Third one, because of those shrinking populations, domestic consumption is decreasing. Okay, so we know that. Okay, if we have to actually reverse this and we catch up like a US and the European, GDP productivity level, and then if you remember the graph of the Masayoshi-san put up, in order to do that, we know the number. We have to have an increase of GDP per capita 6% plus annually and continue for 10 years, and that's moonshot. That's really, really high target. That means we have to have a really disruptive social and industrial change for Japan. That's the only way we can really happily survive. Okay, let's start from labor shortage. Well, three solutions. One, anyone can participate in society. Aged person, handicapped, foreign nationals, it doesn't matter. Okay, can we actually create a technology to be inclusive for those people to be actively participating, or like I place people in the remote locations. Okay, so that ensures certain level increase on the labor population. At the same time, if that is not sufficient, can we actually run the industry without human being? So this is like an automating industry. Third one is a little bit longer. Is one of the problem we're having is a decreased birth rate. So like we're going to increase that. So that's going to be a short-term solution. It's mostly this is a societal infrastructure and framework problem, but at the same time we have something we can do in the science. Okay. So for anyone who can participate, that means we would like to have one of the solutions we propose in this goal is augmenting human capability. So that is basically the cyborg technology, and transporting human capability from one place to the other where they need the service. That means one is the mobility, which is physically transporting, and the second one is an avatar technology, which is like a information or like a remote telepresence. So like this is like logical two-step. One is increase the capability and bring it to the way it needs. So that is the cyborg and avatar part, and then you might need like a precision healthcare, universal medical access, make sure those people are living happily. Okay. And then, so that will actually mitigate the solving medical issues. And then we would like to have second one is automating industries. The sectors we have problem is service sector, agriculture, forestry, and then the fisheries, and the construction sector. Those are the in a place like a serious labor shortage right now. So we're targeting those and automating, particularly like a fully automating will actually change the landscape of the industry, not just a partial automation. So partial automation, everyone doing that. If you think about the complete automation, no human in the loop industry, this industry is going to transform to something completely different. So that's actually moonshot on this industry. Okay, now, then we have like a medical issues and the increased birth rate. We're talking about the third one is that, a lot of social framework. One of the things, the science can do is dramatic improvement in the reproductive medicine side. So we're going to externalize entire reproductive process. We learn from that and move it to the medical care. But that's on the area 3. Okay. So this is very controversial. Okay, so those are combined together. That is actually the leveraging aging society. This is like the chart we built. Okay, let's go to the second one. Save the Earth and the civilizations. The fundamental recognition is we are overloading Earth in terms of the resource demand, the imbalance of material circulation, and that biodiversity is lost. So how we're going to solve this problem is the 3 issues. Reduce resource demand, reduce materials and energy, and restore the global biodiversity. Okay, reduce resource demand, the easiest way is reduce the number of people to 1/10. But of course, without achieving that without catastrophe, it's not possible. So we reduce the loading to the Earth, the resource demand. So therefore, we come up with like a next step, like partition that into 3 sections. One, reduce resource demand. We reduce reduction resource loss to the 1/10, and the reduction of the energy consumption. Energy consumption computing to the 1,000. Okay, so for example, like AI means a little bit computing. Computing is energy expensive. So like we have to really reduce the energy cost for the computing, which probably the quantum computing could be the one of the solution. Okay, and then reuse the material and energy. It's a 100% energy self-sufficiency energy source, which is mean that Japan's energy independence, which is very challenging. And a fuel cycle, a full recycle system for resources and materials, elimination of garbage on the earth, not just stopping it, but retracting it and eliminating it, and elimination of food loss. And those are the things that we reuse and then prevent like all the waste to coming up. And the restore the global biodiversity is construction and environmental neutral city model, and harmonization of agricultural biodiversity transformation, which is more actively intervening into the environment. So those are the logical 3 steps and then all the sub-goals that we can consider on these sections. And that actually combined together become this chart for the sector 2, okay, or area 2. The third one is the, how we can push the science and science by technology. So the intensive integrated technology development and the resource building accelerates scientific discoveries. That was actually the grand arching topic. And we partition, we consider like a measurement, computing, and manipulation is 3 major issues. And then that actually cross-cutting to the quantum level, molecular level, living organism, Earth and space. Okay, so that is all the scale of the physics, like a small to big, can we actually measure, compute, manipulate? And that's a fundamental thing. Of course, like a target is not really covering everything because we have a limited budget, and some of them are better for the focus research rather than the Moonshot. And of course, like data analytics discovery platform is very important. So this echo with Amazon's point, and we're going to be able to share the data and the free flow of information on that aspect as well. And okay, one of the image you can consider like a balance between the Moonshot kind of project in science, also the exploratory science, is a very good example is how the IPS was discovered. IPS was discovered out of nowhere. It's not out of nowhere. It was actually the Phantom project, which is a big project which do the curation of the mammalian genome. And then Yamanaka-san, Professor Yamanaka actually searched the database trying to find out what was the actually transcription factor which contributed to the reprogramming. And then he used the Phantom and he found 24 genes. And then out of 24 genes, he actually identified 4 critical genes. And that's how the IPM was discovered. So this is actually a nice combination of exploratory research with the intuition of the very genius researcher, which actually not came from nowhere, supported by the large-scale science, which actually a lot of effort and a lot of technology to create a database, enable him to drive his intuition into the reality. And this is exactly what we're trying to do. In this, we're going to have like an AI scientific discovery and digitization of the regenerative process in human hibernation, creation of digital model entire nervous system. A lot of people doing the brain. But we want to focus on not just brain, the peripheral neural system, intestine, and the immune system interaction, which actually has a relatively underrepresented area. And also, we're going to have like a quantum computing, measurements underwater. This is the space, and then the Earth, measuring the space, which is the solar system. And we're going to have like a persistent presence in the space. That means we're going to have a constellation of satellite, and which operate permanently in the space, or like probably manned space, habitations. That is actually, this area. Okay, so, and of course, like those targets is not standalone. It's very much interlinked. Okay, if we do that, what we can do here is this area in left up corner, which substantially improve the health and wellness for people. That's basically live long and prosper. Okay, and you have those sector, which is a cyborg and avatar, and which enable us to move around anywhere we want, and then overcoming all the incapabilities we have, and all the sectors are all like distributed collected space, and then avatars and hibernation, all that enable us to go deeply into the space by ourselves. That's what that's end up going there. And also like a terraformation technologies and also recycling, which actually we're able to save the planet. Okay, so if we are able to terraform the Mars or outer planet to migrate into that, we should be able to solve the problem on this planet. So why not don't abandon the planet, save the planet, also expand our terrain into the space. Okay, so that's actually the matrix which is connecting things together. Okay, so that we have like this mandala diagram which showing the crude classification of all the goals, and then we have like a working group which will have a spend tomorrow coming up with a much more precise goal, which goal to pursue, which one to be like take it for the later days, things like that. Okay, now we have like all the connections of that. Now we're back to there. Now we're talking about the Moonshot, but don't remember that we have focus area and exploratory research. Those research funding is very important, and Moonshot is not really the single research program. At the same time, what I want to focus is like when basic research is concerned, the Moonshot is concerned, it's not just like a focus and job or other thing. We should have a strategic focus. At the same time, we should have like a broad support for the exploratory space. So rather than the focus and centralization funding, we should have a strategic and exploratory funding to balance out the strategic, high, big project, and then tail size, like small funding, but like a stable and exploratory funding. And it's very important because most of the disruptive discovery came from the exploratory side. And that's very important to mention here. So actually, this is, I think, the last slide. Is at the end of the Vision Council, I made a prediction, actually. This is my slide. Okay, so this Moonshot is designed to be very challenging. Okay, I think we can have like a 50 to 70% achievable what we can envision. We have a lot of make effort. We need the innovations. We need like a lot of discoveries and technical breakthrough, but I think we should be achieve quite a bit of that. And that was sufficient to change the society. But the final goal was designed to require discovery, basic scientific discovery in most of the things. So that means not only the big funding like that, we need exploitative funding coming together in a broad area, because we were talking about social transformations, not only science. We need funding on the humanities. We need funding in social science. We need behavioral psychology, because the society needs to be changed. We need to understand how that can be achieved. At the same time, progress in basic science and material chemistry, biology, you know what? You don't know what coming out of this. This is very important. And also, we will consider major contribution art and design, because we're going to have to change the society. Societal involvement is very important. Citizen participation is very important. Art and design are going to be very critical in interfacing and having outreach, and has a serious impact on how these things can be implemented. So that means we need not only the Moonshot research funding, we need exploratory research funding. And fortunately, Japanese government announced it's a tentative name, but like some kind of blue sky fund at the scale of $500 million US, which is about half of the Moonshot funding. But still, I think that's a very good, relatively long-term, small, but a stable funding for the exploratory research, where people can just do crazy research. Okay, so that's what we have done. And we just mentions, we have determined to achieve the Moonshot, whatever you think is crazy or not. I think this is the phrase I love a lot. This is what Stephen Jobs says. The people who are crazy enough to think they can change the world are one who do. So we should believe that we can change the world, and let's go for lunch. Thank you very much.